All right, this is part 2 of lesson 6.3. So here we're going to solve a system by multiplying both equations. And if you look closely at these equations, you'll notice if you added them together, you would get 5x equals negative 5y, or 5x minus 5y. If you subtracted them, you get negative 2x equals minus 1y equals negative 14. So in either case, you don't eliminate the variable. And there isn't one number, unless it's a decimal number, that I can multiply either equation by that'll allow me to add the equations together or subtract them to eliminate the variable. So I think the easiest way to do this one would be to multiply both equations by some number. So, and there's a number of ways you could do this, but what I'm going to do is I'm going to multiply the top equation by 3, and I'm going to multiply the bottom equation by negative 2. And notice 3 is the coefficient of the second equation, and 2 is the coefficient of the first equation. Think about what's going to happen to those first two numbers when I do that. We're going to have positive 6x and negative 6x, and then I can just add the two equations together. So there's my work. That's what I want to do, and I end up with these equations. 6x minus 9y is equal to negative 36, and negative 6x plus 4y is equal to negative 4. Now, if I add the two equations together, 6 plus negative 6 is 0, negative 9 plus 4 is negative 5y, and negative 36 plus negative 4 is negative 40. Divide both sides by negative 5, and we get y is equal to 8. Taking one of my original equations, 2x minus 3y equals negative 12. I'm going to substitute 8 for y and find x. So 3 times 8. And then I get 2x minus 24 is equal to negative 12. Adding 24 to both sides gives me 2x equals 12 and x equals 6. Now I'm going to check to make sure that works in the second equation, which is 3x minus 2y equals 2. So 3 times 6 minus 2 times 8 should equal 2. 3 times 6 is 18, and 2 times 8 is 16. 18 minus 16 is 2. So that's good. All right. So go ahead, you try solving a system by multiplying. You can go ahead and do it. I'll work our way through this one. So we're going to multiply by 3. So we get 3 times x plus 9 times y equals negative 57. Multiply the bottom one by negative 4. We get negative 12x plus 8y equals 40. Now we can add the two equations together. Oops, I saw a mistake already there. 3 times 4 is 12x. Then 12 plus negative 12 is 0x. 9 plus 8 is 17y. Negative 57 plus 40 is negative 17. And negative 17 divided by 17 is negative 1. To find the other value, they've done it for you. You just have to complete the steps. So this first step here, they're substituting negative 1 for y. Second step, they are adding 3 to both sides. So using the addition property of equality. Then they are just simplifying. Negative 19 plus 3 is negative 16. Then they are dividing both sides by 4 to solve for x. So the solution is negative 4, negative 1. All right, finding the number of solutions. So how many solutions does the system have? Okay, System will have one solution if the lines cross. So basically, if they intersect, there's one solution. A system will have no solutions if the lines are parallel, and a system will have an infinite number of solutions if the lines coincide. In other words, they're the same line. So we can think about slope here. If the slopes are different, there are two solutions, or there's one solution, one for x and one for y. If the slopes are the same, we have two things that can happen. If the y-intercepts are also the same, then there's an infinite number of solutions. If the y-intercepts are different, then there is no solution. So what I'm thinking here is we should, and there's a number of ways we can do this, but one way you can do is just find the slopes. Another way you can do is to use the addition method and just subtract. If you get an x value when you're subtracting, then obviously there's one solution. If you get a true equation, then there is an infinite number of solutions. If you get a false equation, then there's no solution. So let's just see what happens here. Let's take the bottom equation and multiply by 4. That'll give us the same coefficient for the first term. We'll have 12x on both of them. When we do that, here's my first equation again. My second equation, I get 12x minus 8y equals 20. So we have the exact same equation. Now if you subtract them or add them or whatever you do, you end up with an identity. So there's an infinite number of solutions. And if we were to solve these for y, I'm going to do this quickly, but in the first equation we would get y equals 3/2 x minus 2.5. Or 5/2. And so the slope is 3/2. In the second equation, if we solve it for y, we get y equals 3/2 x minus 5/2 also. So we really have the same two equations. Same slope, same y-intercept. Those two equations will coincide when we graph them. There's going to be an infinite number of solutions. All right. So here's a lesson check. Add each system of two linear equations together. The first one we get 3x equals 18. Second one we get negative 4x plus 9y equals 7. Which system of equations, A or B, has a sum that is an equation in one variable? That would be A. How can you use the equation in one variable to solve the system of equations? Solve for x. Then substitute into the equation for y. And when you use an equation in one variable to solve system of equation, what method are you using to solve the system? This is called the elimination method. All right. I'll see you tomorrow.